Okay, now I want to talk about the zero exponent. We're going to use what we have already done here. And so we would know that when we're dividing exponents, or dividing powers, we're subtracting the exponents if they have the same base. So in this case, it would be 3 to the 5 minus 5 power, which equals 3 to the 0 power. Okay, if you think about what this would look like, so we'll use the simplified over here. So we have 3, 3, 3, 3, 3 over top of 3, 3, 3, 3, 3. Then you're going to notice that all of them are canceling out. Gone, 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 and gone. And so all you would have left here is 1. And so what I need you to see is that anything to the 0 power is going to equal 1. Let's try it here. If I look at it from a division standpoint, I'd have a to the 4th minus 4, and then that equals a to the 0 power. 4 minus 4 is 0. If you look at it long ways, you have your 4a's, and then when you divide them by, when you divide them by 4a's, then you get, they all cancel out, and so all you would have left with is 1. And so again, anything to the 0 power will equal 1. Let's do it one more time. Here we'd have n to the 6 minus 6. That's going to equal n to the 0 power. Again, I'm hitting Control plus if you're wondering how I'm typing exponents so quickly. What that looks like here is I have 6 n's. If I divide them by 6 n's, they are all canceled. This equals 1, 1, 1, 1, 1. So the only thing you really have left, I have no idea what just happened there. Let's see, is 1. Geez. The only thing, or the thing that I want you to notice with this, is that anything to the 0 power equals 1. So what does that look like in a rule? If I have a to the 0 power, it just equals 1. It doesn't equal a. It's like saying that there's 0 a's there. And when you're multiplying, the only thing that's left, if there's nothing there, is a 1. So anything to 0 power equals 1. Doesn't matter how big or scary the exponent is. So now let's go through here and drag each number correctly. So this is just, again, to kind of practice what we've done and to show a new pattern. So 2 to the 4th power. So if I took 2 times 2, that's 4, times 2 is 8, times 2 is 16. I totally did that wrong, didn't I? 2 times 2 is 4, times 2 is 8, times 2 is 16. Nope, okay. And then 2 to the 3rd power, 2 times 2 is 4, times 2 is 8. 2 squared, 2 times 2 is 4. 2 times 1 is 2. 2 to the 0 power. Oh, I said 2 times 1. 2 to the 1st power is 2. 2 to the 0 power, anything to the 0 power is going to equal 1. Then what you're going to notice that happening, remember, if you have a negative exponent, it goes to the bottom of the fraction. So it's like 1 over 2 to the 1st power. Well, 2 to the 1st power is 2. So you get 1/2. 1 over 2. Oh my, why won't you move? What is the deal? There we go. So then here, negative exponent, so you know it's going to be 1 over 2 squared is 4. So this one becomes 1/4. And then 2 to the negative 3rd, so it'll be 1 over 2 times 2 is 4, times 2 is 8. And then finally, 2 to the negative 4th power, 1 over 2 to the 4th power. 2 times 2 is 4 times 2 is 8 times 2 is 16. Let's see if I can scoop this one up a little better. Okay, now the other thing, when you see these all together, notice that 2 to the 4th and 2 to the negative 4th, the only thing that's different is that there's a fraction. And so I wanted us to do this so you could see the pattern of what's happening here. Okay, so those are the end of your notes for pages 39 to 41. Please let me know if you have any questions, and we will be practicing this for the next couple days. Thanks.